Number 4. A sphere of density and radius r rest on the bottom of a tank of water. Now the buoyancy force on the sphere is given as F1. So this is the first sphere. And a sphere of density again, that is twice the density of the first sphere, and radius r/2, or half of the radius of the first sphere, is at the bottom of the same tank. The buoyancy force on the second sphere is F2. Now the question wants us to find the ratio of the buoyancy of the first sphere divided by that of the second sphere. Now let's look at a detailed solution for this question. Now first and foremost, let's define what buoyancy force is. Buoyancy force, mind you, is the same as upthrust. And upthrust is a force that acts on objects immersed in fluids and tries to push those objects up. So that is upthrust. Now the formula for buoyancy force or upthrust is given as density times volume times gravity. So the symbol you are seeing there is called rho, R-H-O, rho, and it means it's a symbol for density. So from the question, we can write that our buoyancy force or our upthrust is given as density times volume times gravity. But mind you, there's a common solution I know students to use, and that will lead you to getting an answer of 4, but that is wrong. So I'll take you through that wrong approach first, and then I'll take you through the correct approach you should use. Now, I know that students will write that the buoyancy force F1 is given as a density of the sphere times volume times gravity. Now, what you should note is that volume of the sphere immersed in the fluid is the same as the volume of fluid that is displaced. Okay, now our fluid in this case is water, so we just use V to stand for the volume, and that is the volume of the sphere, which is equivalent to volume of fluid displaced, because the sphere was totally immersed in the water and was underneath the tank. So going back to equation 1, here we are writing that, or student will write that the buoyancy force, or F1, is given as density of the sphere times 4/3 pi r cubed times g. Now let's look at the buoyancy force for the second sphere too. So for that of the second sphere, you'd multiply it by 2 like the question is saying. So you'd go ahead and you multiply it by 2, and then you'd multiply also that by the volume of the sphere again, whose radius is now r/2 of the first one. So that should give us 2 times density of sphere multiplied by 4/3 pi into bracket r/2 cubed, all multiplied by g, and that will give you density times 8/3 pi r cubed over 8. If we simplify this, we are getting the expression in equation 3, which is density times 1/3 pi r cubed multiplied by g. Now when we go and we compare, like the question wants us to find ratio of F1 over F2, we compare the two of them. Most of the expressions are common, so they will cancel out. These will cancel out, so we'll end up getting our ratio of F1 and F2 to be 4. But like I told you before, this answer is wrong, and I'm about to tell you why this answer is wrong. This answer is wrong because of this. Now let's rewrite our formulas again. So density for the first sphere is given as, the buoyancy force for the first sphere is given as density times volume times gravity. But mind you, the formula for the buoyancy force or upthrust is density of fluid displaced times the volume of fluid displaced times gravity. It is not the density of the sphere that you are using in this case. You are using the density of the fluid displaced, and in this case our fluid that we use is water. So rho in the formula is the density of the fluid displaced, not the density of the object. The mistake in the first one that most students will do is that they will use the density of the sphere instead of using the density of water. So going back to equation 1 that we've just written there, we'll get that our buoyancy force is given as density of water into bracket 4/3 pi r cubed times g. Now for the second sphere, what we should know is that it's the same fluid that we are using, it's the same water. So hence, although the density of the sphere is doubled, the density of the water is not affected. So the density of the water still remains the same. So density of water remains the same in second sphere, just as it was in the first sphere. So Our buoyancy force for our second sphere is giving us density of water again 4 over 3 pi r over 2 all cubed times g, and this will give us 1/8 density of water 4 over 3 pi r cubed times g. And when we do the substitution, we will get our F2 to be equal to 1/8 of F1. Mind you, this is F1. F1 is giving us equation 2. So you realize that we are getting the same thing in this part. So the whole of this one is standing for F1. So we can just do the substitution there, and then when we simplify, the ratio of F1 over F2 is equal to 8. Mind you, this is a very, very important solution. So our correct answer is not 4, but our correct answer is 8. Let's go back to our question. So from our question here, we will know that we see that possible answer is A is 2, B is 4, C is 8, D is 16. So from all of this, straight away, our correct answer is C.